Hi everyone!
Hey,
Welcome to this new episode of Hands-on AI, where we walk you through step by step on some AI labs. I'm Annie,
I'm Io.
and today we're gonna explain a multi-agent lab. So by the end of today's lab, you can learn everything from MCP server to ADK agents, all the way to agent protocol. Are you excited, Io?
I'm super excited. That sounds so really fun. But before we get started, it's also important
Yeah.
for those of you who want to follow along with us, make sure that you have
Mhm.
a few things set up in your environment. So we always recommend using a laptop or desktop. If you
Don't use your phone for today's lab.
exactly, and two, make sure that you're using a personal Gmail account. I know a few of you like to use a corporate or educational account. Sometimes
Mhm.
those come with restrictions, so we always recommend using
Yeah.
a personal Gmail. And
Yeah.
that said, outside of that, Andy's going to now walk you through a few billing enablement steps, just so you can
Yeah, sure.
redeem credits that
Uh-huh.
are free for the lab and link them to your project.
Yeah, also I forgot to mention this is a two-part series. And today I'm gonna lead you for the first part. Tomorrow I'm gonna lead you for the second part. And by the end of this two-part series, we're gonna have a boss fight because this is RPG games thing. Are you ready for the boss fight, Io?
I'm super ready. Yeah, let's go.
Yeah. Okay, so before we claim the credits, you probably have seen the link on the screen or in the chat about the link for today's credits. And let me walk you through how to claim that credit. So this is the link. You may see a different title over here, but essentially this is just to help you to, you will see this button. Click here to access your credits and making sure you sign in with your personal Gmail account. Okay, I'm clicking this button. You will see that it's opening a new window and I ask you to redeem, claim this credit, and just making sure every information is correct and accept and continue. Okay, so you will see credit successfully applied. That means you have successfully claimed your credit. For those of you, some of your screen may show up like a payment method requirement, but you did not need to input any personal payment information. If you saw that window, you just close that window. Don't worry about it, and let's get started.
I'm super excited. Okay, so it looks like now we're going to be diving into steps 1 through 5 of the lab,
Yeah.
as Andy
Mhm.
mentioned. And then for tomorrow, we'll cover steps 6 through 10, which involves A2A, building callbacks with the ADK system.
Yeah.
But let's first learn what is MCP, and Andy's going to walk us through the overall architecture, and then we'll do a deep
Yeah.
dive.
Yeah. Thanks, Al. And you can take a look at this high-level architecture picture. And this is the multi-agent system we're gonna build. And you can take a look you can look at this diagram from bottom to top. And the bottom layer is tooling layer, which is I mentioned we have different type of MCP server we're gonna build today. We're gonna build custom MCP with API or general function. We're also gonna use what is it, IO? What is the type of MCP server? Another type?
MCP server through Data Toolbox.
Toolbox.
It's a really good way of connecting with databases. It provides you all the configuration code that you need. So we're going to learn two different ways as part of this lab. Again, as mentioned, connecting with MCP servers through external APIs, but also through Data Toolbox. And also there's another new way called MCP managed servers through Google.
Google managed MCP server.
Google managed MCP servers, but we'll cover that later on.
Yeah, all right. So this is a tooling layer. And once we build a tool, we need to connect the tool to our agent. So the second layer is domain workflow. We're going to cover how to build ADK agent, more specifically workflow agent. So we're going to cover different type of workflow. That is sequential ADK agent, parallel ADK agent, and loop ADK agent. So once we connect the tool to our ADK agent, we have like different specialized agent ready, right? So the last step is at the very top, we have this orchestrator agent, the root agent. This is agent standard. We want to like orchestrate everything together. So this is through our agent-to-agent protocol, right, Io?
Exactly. So agent-to-agent protocol, which we'll cover later on as part of day 2. Tomorrow is a really good way of connecting agents with remote agents, going cross-organizational boundaries. So if you have within intra-boundary organizational boundaries, local agents makes a lot of sense, but oftentimes you need agents to communicate with other agents across boundaries.
Yeah.
So
exactly.
Yeah.
Yeah. So if you're curious about A2A, you have to come back for tomorrow's episode. And you can also see that on this diagram, we have like state and memory, right? So we're gonna also touch a little bit about ADK agent, memory, and state. And we also have ADK plugin here. If you're curious what it is, you have to come back for tomorrow.
Yep.
Right? Okay. All right. So let's get started for today's part. And because I already claimed the credit, so what I need to do now is I'm going to step 3. On this page on the left, step 3 is join the summoning circle, and you just basically go through everything following the instruction over here. And as you can see, the very first step is we need to activate Cloud Shell on Google Cloud Console. So that means we need to first open the Google Cloud Console. And basically, I just type Google Cloud Console. And then I'm going to Google Cloud Console, click this. So or you can just simply go to console.cloud.google.com, right? So on the top right, there's a button called Activate Cloud Shell. So I'm clicking this button, and I'm going to open Cloud Shell environment. And this is where we're going to code it for today. This is basically like VS Code on cloud, right, IO?
Exactly. Yes.
Okay.
Yeah, and one thing to keep in mind is, as Andy mentioned, it is kind of like VS Code for cloud, so it is persistent files. So this Cloud Shell is essentially a remote VM, so you can come back to it. So whatever files that you create today as part of the lab, you can start and stop if you want to. Come back 2 days later, the files will still be there.
All right. So you can see that we have our terminal open on this Cloud Shell. This is basically the terminal, similar to terminal for VS Code. How I usually like to navigate is I like to open this in a new window. Okay, so if you open in the new window, you can see on the top right, we have this open editor and open terminal. So I usually like to click open editor and open terminal so that we have both editor interface and terminal interface. Now I'm coming back to my instruction and ready to run more commands. So those are instructions, basically just open the editor and open the terminal. So now we have the terminal open. The first step is let's do gcloud auth list. So making sure you're already authenticated. So I'm coming back to this terminal and I'm pasting the gcloud auth list to making sure, this account is authenticated. And then what's next is let's clone this project. So I'm copy this command, copy those command and go back to my terminal. And I'm gonna paste it over here. So what it does is it will clone this project. Why we have 2 projects that we want to clone?
Great question. So for the Agentverse Architect, it comes with a lot of starter files and template configurations for essentially the multi-agent system that we're going to build. But also, again, as Annie mentioned, essentially we're going to be building up to a boss fight in the cloud where our agent that we're going to build is going to be fighting with this monster that's also another agent. So they're going to be communicating via A2A to kind of get that dungeon environment set up. That's kind of stored in a separate GitHub repo. So essentially, you have to kind of clone that and kind of just build it ahead of time. So by the time we build our multi-agent system, we already have a dungeon environment that's already built. So that's pretty much why we're downloading 2 separate GitHub repositories.
Yeah, thanks for explaining. And next step is let's run this init script. I copy this and paste to our terminal. So you can see that once we copy this, it will create a new project for us. And right now, it will create a name start with Agenverse Summoner. So I'm running the Agenverse Summoner. So you probably see a different name here, but usually it starts with Agenverse Summoner. So what it does is it will create a new project for you, and then it will link the billing account you just claimed and link that billing account to this new project so that you have this new project that has a billing account attached to it. And if you successfully run this command, you can see this yellow font that is a project it's setting that is correctly set to our environment.
Yeah, and all we're pretty much doing, again, as Annie mentioned, is linking the billing account that was redeemed with the project that's been created.
Yeah, so this step is making sure you select the project you just created. So what I do is I'm coming back to this Google Cloud console. This is console.cloud.google.com. And then on the top left, this is a project selector, right? And on the all tab, I'm selecting this project that's just created. So now I'm currently in the Google Cloud console. I'm selecting the project. Great. And now let's come back to set the project ID if needed. I'm copy this and then paste it over here since it's already set to this project. So I should be good to go. And next step is we need to enable some Google Cloud APIs. Let's see what the API we want to enable here. We have SQL admin, storage, API, platform, cloud build. Do you know why we need to enable those API?
Yeah, great question. So for something like AI platform, Google's APIs.com, that's essentially the underlying, APIs for Vertex. So when we're communicating with Gemini behind the scenes, essentially leveraging the Vertex API. For something like cloud storage, we may be storing assets like media files in Google Cloud Storage. Essentially, you want to make sure that your project has these APIs enabled. One question that comes up often is, when you enable APIs, are you going to start incurring cost? Just by enabling APIs does not mean you're going to have a cost in your project. Essentially, just makes sure that these services are available for use.
Great. Thanks for the explanation, Io. So while we're waiting for this command to run, API to run, maybe we can talk a little bit more about the MCP server we're building for today, right? So just to give you a quick overview of what is MCP server, right? Because we just assume I know MCP server, just give a quick overview. That first, before we know what is MCP server, we need to understand what is tool, right? So tool, basically, agent, in order for agent to connect to the external world and do some action for you, you need to have a model as a brain and connect external world through the tooling, right? And then here we have MCP server. So you can take a look at this picture. That on the left-hand side is MCP client. It's an agent client side. And on the right-hand side is the MCP server. Basically, for agent that's connecting to the external world, you will call those MCP server through here. But why don't we?
And not to cut you off, but also when she says external world, essentially there are limitations that come inherent with these models that kind of are the brain behind these agents. So while these agents may be powered by something like Gemini, which is really powerful and really good for multi-step reasoning, it doesn't have access to real-world information. So let's say use case such as, give me the current exchange rate between the USD and the pound. That's not something it has access to, but it could leverage a tool to get that information. Also, there's use cases where you may not want an LLM to be doing math because it's been shown that when it comes to some things like math, it may not be as good. But what you can do is have it connect with a calculator tool that's a little bit more deterministic. So there's reasons why, again, tools make sense to use in context of agents. Then Annie's now going to explain essentially how MCP kind of expands on that same, reasoning.
Yeah, so actually in today's lab, we actually have a general function that is doing the calculation. So that's a great example of building an MCP server that's doing some math calculation. Also, for Gemini, it actually grounding with Google search. So if you're using Gemini model, you do not have to, if you look for current currency, the model itself actually can do the search. But if you're using different model, it may not have that Google search capability.
Yeah, it may not have a Google search tool, but there are open source third-party tools that kind of link to real-world kind of web data. So there's alternatives.
Yeah. So MCP server is like this universal adapter. So whatever tools you're connecting to, whatever like MCP tooling, and you connect to this universal adapter, so that MCP server this tool can basically connect into any type of agent, no matter it's ADK or if it's a different agent framework on different cloud, deploy on different cloud, right? So MCP server really allow you to do a complex design, and it's a standard protocol for agent to communicate with the tooling. And let me go back to this stage. So once we are successfully enable the API, and let's continue to do this create artifact repositories. essentially we want this so that we can eventually do the deployment. Would you mind explain what are the artifact repository here?
Yeah, so artifact repository is essentially Google Cloud's, container image service for hosting. So essentially,
Cool.
later on in the lab, we're going to build container images for each of the agents that we kind of define in the code, and then later on deploy those agents to Cloud Run by essentially pushing those images to the Cloud Run service, or deploying those images to the Cloud Run service. But essentially, artifact registry has to kind of host all of those images. So we're just building our namespace for those images ahead of time.
Yeah. And if you see this command currently has nothing equal, or if you see the URL is empty, that's completely expected. So do not have to worry about it. And we can continue to do the setup permission step. So just copy okay. I guess I happen to copy this. I'm going to copy this and come back to the terminal and making sure. So right now, I am just adding those permissions so that my service account now able to have those roles to connect. So for example, I have service account now able to have these roles to manage the storage, and also have a service account to manage the to do the cloud build editor and more.
Yeah, and just to kind of echo that statement, in Google Cloud, almost all actions occur under an identity, whether it be a user identity or what's called a service account identity, which is essentially the identity of some sort of service. So essentially, if you want to be logging or deploying, you have to make sure that your default service account has the ability to actually write logs or to deploy. So it's just an additional step.
Yeah, it's like a robot account of yourself and trying to do all those action on cloud.
Yeah.
Great. So next step is let's try to run this command to deploy our dungeon, because you do not have to do anything to build a dungeon. You want to first deploy them, so later on you can do the boss fight 0A to A. And let's run this command, and we're going to have a deployment process kickoff. But this is not a black box process. Other than the command, like a log you're seeing on the terminal, you can also open Google Cloud Console. I guess we already opened it here. And I can search cloud build to see the current building process. So I search the cloud build, and I'm going to open this cloud build history. Right now, I haven't kicked off. I guess I was running the, okay, so it's submitted in the background. Let's see, let's refresh it and see, does it start okay, so it started build. I'm going to click in the build, and you can see this is a building process. And let me zoom out so you can see that this is the auto step how it is building behind the scene. So once it is finished, we will see this deploy to Cloud Run. So I'm going to search Cloud Run, and right now we're not supposed to see anything because it's still in the deployment. It hasn't deployed yet, and we will check that, but at the very end. So while we're waiting for the deployment, because it's still deploying, let's continue for our prepare script. So just copy this script and paste it to the terminal. And here we are preparing our environment, finally ready to build this multi-agent system.
Yeah.
Great. And so while we're waiting, we're going to talk about what are the tools we're going to build. What are the MCP server we're going to build? Because before we talk about why we need MCP server and what is MCP server, right? So now we're going to talk about how to build different type of MCP server. So all right, let's take a look at how to build those MCP. And here we are using our ADK to build MCP. And on the right part is how to use ADK to build MCP server that wrap the external API. And also we have this MCP server that implement a general function. That's basically what I previously mentioned, that you can do a math calculation, right? So here is an example of how to build MCP server, do the mathematical calculation. On the left, we have MCP server with database toolbox. Basically, you're building an MCP server that easily connect and fetch and query this external database. Here we have this cloud SQL data prepared for you. And the very first MCP server we're going to build is external API type of MCP server with ADK. And let's take a look at how to use ADK to build MCP server with this external API type. Let's go back to how to do it in the code. Okay, in this code, you can see that first you need to navigate to this directory, right? So what I'm doing is I'm copy this file, and then I'm going to this editor. So right now you can see that I already have this file open. But if for those of you who don't have this open, you can go to like top left, this file, open folder, and select the architect, our architect for today. Because the dungeon is the one that the boss want to fight. So you do not have to touch dungeon. You just open the architect and click OK. It will open the architect folder for you. And in the architect folder, let's look for this MCP server /API /main file. So now I'm currently at this main file. And what I need to do is I need to replace this magic core. I'm copying this and paste and copy this code to the magic core. And let's take a look at what does magic core mean. So here we are creating those two functions, and each of them are wrapping those API, right?
Yep.
And then what's next is in the same file. So same MCP servers API main file. You need to replace this one. Just search for things we want to replace, and let's copy this to the things we need to replace. Yeah. So what we do here is we have this annotator that wrapped the list tools and call tools. So here is how exactly you're using ADK to create the MCP server. But why list tool and call tool? So early on, we have this file that, when ADK is connecting to MCP server, that first it will load all the available tool. And once model decide, okay, I'm going to use this 2A or 2B, you're going to call the corresponding tool. Yeah. Right? Anything
Exactly.
to add?
Exactly. No. That's the exact workflow. Client to server response.
Yeah. So here we are creating those two tools, and they are wrapped with different endpoint. So we basically finished this. So we finished the first type of MCP server, with external API, right? Because you just wrapped them. So those are basically Crystal Shadow and Moonlight Cascade, right? Did I pronounce it correctly?
Yeah, Cryo Sea Shatter and Moonlit Cascade. Yeah.
Yeah. Thanks.
No problem. Yeah.
Okay. So next one is, let's take a look at this general function MCP server. And basically at a general function, you also go to this MCP server, but now we're at general folder. Over here, that you can see the code are pretty similar. First, you have this type of tools. How to say this? This is a game.
Leviathan Search.
Okay. Leviathan Search.
Yeah.
Another one is
Seismic Charge.
Seismic Charge. Cool. So you can see that it's actually doing the mathematical calculation, right? And here is you're creating this function tools over here. And in the list tools, you're also using ADK to MCP2 type so that you're creating this MCP2 type. Okay, let me go back. Yeah, so you're creating this MCP server tool with general function. So now we have this two MCP server created. Let's deploy them to Cloud Run. And so what I'm going to do is I'm going to copy this command and paste it in the terminal, not to the file, to the terminal. And let's take a look at what is the code we called. So we run this gcloud build submit, and we're using this cloud build.yaml file. Do you know what is cloud build YAML file and why we are deployed this way?
Yeah, so Cloud Build is essentially like Google Cloud's engine for CI/CD. You can use it to automate and build, various things such as services or run pipelines. So for our particular use case, we're using the Cloud Build YAML file to automate a few steps. One being the building of the container image. That's gonna
so here is a build container. As you can see, we built two container. simultaneously because we have two servers we want to deploy.
Exactly. Then the next step, as we talked about earlier, artifact registry is essentially where we host and kind of store the container images. So once we build the container image, we're going to push it to the artifact registry namespace that we created earlier. Then finally, after we've done that, essentially we can then deploy that same image to Cloud Run. And then if you scroll down, you can kind of see all the parameters that we're adding to the Cloud Run deployment. So Cloud Run is essentially a serverless service for Google Cloud where you can run, micro apps and various other things, but overall it spins up and it spins down when you're not using it. So you can set things such as max instances or min instances.
So this is the Cloud Run service over here. And that's also, again, you can also see the build process. If you search Cloud Build, you will see the process that the deployment process over here. You can see that previously we have two build successful, right?
Yeah.
Okay. So while we're waiting for the deployment, we can see in the Cloud Run console, we should be able to see the things that's deployed. So again, making sure when you go to the Cloud Run console, you're selecting this agent project. And okay, am I at Cloud Run or Cloud Build? Cloud Build. Okay, let me search Cloud Run.
Yeah, so at this point, if you recall, what we've done so far is we created the dungeon ahead of time. So for right now, all you should see is pretty much the dungeon, as well as it looks like the API was able to deploy really quick as well. So
so I think the API is the one that we are we will preload this in the script. I think the two is still currently deployment.
Okay.
Yeah. So it looks like still deploying. And so while we're waiting for the deployment, we can go to the next tab of MCP Server, which is Database Toolbox MCP Server. And let's take a look at what is Database Toolbox MCP Server, right? Okay. So as you can see here, that we have this database in Cloud SQL. Those are all the available data, and then with the MCP Server Toolbox, basically you're implementing a tool to easily access or query or control connecting to that database. Like I am curious, if I'm not using Database Toolbox, if I simply just build a normal MCP server, how would I connecting or query this? How would I build an MCP server that query from this?
Oh, sure. Great question. You would probably be leveraging within the logic of that custom MCP server, logic that authenticates and then kind of executes commands against whatever database, whether it be something like Cloud SQL or Cloud Spanner and so on. The nice thing about MCP Toolbox, Database Toolbox, is that it kind of normalizes all the configuration across all these DBs. So essentially, you don't have to kind of worry about creating custom, MCP servers for each database. You can kind of connect directly with MCP Toolbox, configure it directly there, and then start interacting with different databases directly with via an agentic system. That's the benefit. Simply, it accelerates your development velocity.
Yeah, and MCP Toolbox is also able to connect to many different types of database. And today we just only have this example. But if you go to the doc on the screen, you can also, check how many database you can connect to. And let's take a look at how to connecting to this database toolbox, using Database Toolbox to connect into Cloud SQL. Right? So let's first do the data setup command. I copy this and paste it to the terminal. Okay, it's still deployment. I'm gonna open a new tab. So I'm gonna paste it over here. Basically, you will first activate the environment for me, and then go to our project, and then run the script to set up so that we can use the MCP Toolbox. And then later on, so first, it will making sure we have this SQL data we connecting to. So those data setup command is basically to set up this Cloud SQL with some data that we're gonna interact with, because we need to have a database so that and then we're building this tool to connecting to that database, right?
Yeah. So first create data, seed it in the database, and then interact with that data via the MCP Toolbox.
Yeah. Looks like it's still storing the data. And And yeah, okay, great. So right now, we have this ready. We have this data instance ready. So I'm gonna like copy this. Oh, okay. I'm gonna copy this console and paste it, and making sure that this is agent words, right? As you can see, this Cloud SQL include Cloud Console, and in the Cloud SQL Studio, you can see log in to your database. We need to follow the instruction to log in. And here is the instruction. And in the login page, you need to first select familiar. And then you need to enter Sumner as user. So I put Sumner as user. And then this is the password. So once we authenticate, we're able to see this data in this table. Great. So we can give a try by let's copy this and open this query and then paste it. So here are all those existing, different type of file familiar name. We have this Infernal Lash. I don't know how to pronounce this.
Yeah.
You can tell I don't play many games.
Ember Storm. Yeah.
Do you play?
But overall, essentially, we're building an agent that, given what we call kind of an elemental, it would know exactly what type of attack and ability to kind of, leverage to inflict the most damage. So again, this is an RPG role-playing scenario. So essentially, we've stored different types of familiar names, the abilities, the damage points, and the element that it's for directly in a database. So whenever our agent needs to know what to do, it can kind of run the MCP server tool, get this access to this information, and then leverage it as part of its delegation and response. So we're going to see that later on. But that's essentially the overall scope of what we're building.
Yeah, thanks for explaining. And before we move forward, I want to making sure. Okay, I guess you don't have to worry about other MCP server. Okay, let's take a look at how do we connect into that database. So I'm opening this MCP server toolbox. So go to the db toolbox tools.yaml file. So there's also this config file. That's okay. Sorry, I guess I'm opening the wrong file. Yeah. So this is a config file to configure what is the database we're connecting to, what are the tools I'm creating, and how to implement those tools. And let's take a look at each of them. So first, we need to replace the source with this code. This is basically connecting the SQL we just created. As you can see that this project ID, we need to replace this project ID with the real project ID. And then to get the real project ID, I'm going to my Google Cloud Console, right? I can just copy this from the IDE. Or you can follow some, I think we have some command to get the project ID. But again, this is the easy way, right? So just go to the Google Cloud Console and then making sure grabbing the ID from here. And then so I'm copy here and I'm gonna replace this your project ID placeholder with a real project ID. And what's next is we need to replace existing tools. Let's see what tools we want to create. We want to create this lookup ability to be able to look up in this look up all the ability available and what are the damage for each ability. And next is let's put everything we create in this tool set so that those two tools we're gonna put them to the tool set. And if you take a closer look, you can see that this statement is actually a SQL query, right?
Yeah, exactly. What I really find interesting about this YAML file is that when you compare it to the Python code that we edited earlier with ADK tools, essentially what you're learning is two different ways.
So this is a tool. We are doing this earlier. We have to creating this in the Python function and then wrap them with this annotator. And here we are just doing them in the config file, right?
Exactly. Yeah, it's kind of declarative versus imperative ways of defining the tools. Yeah.
Yeah. Sorry, what did you find it interesting? You find it's very different.
Oh no, just two different ways of essentially defining tool sets. So you can do it through code, when you're doing it more through like through file-based configuration. Some people like different approaches, and each has their own benefits. But I just wanted to point out, essentially we're learning two different ways of building tool sets.
I was showing the cloud YAML file. It should be the tools YAML file. Great. So let's continue and continue to first create the secret by copy this, and I'm gonna paste over here. So essentially what it does is it first need to create the secret, and you can see the secret on the secret manager. Secret manager on Google Cloud Console. And here we have these tools. This is basically the tools you just created. If you're trying to view the source value, and this is the tools YAML file we created, right? And next is we want to deploy this to Cloud Run as well. So you just copy the deployment code and paste it to Cloud Run. And here, it looks like we're now using the Cloud YAML file. So here we directly deploy this toolbox because we have this toolbox image from this framework library, right?
Okay. Yeah.
Great. Let's take a look at what are existing tools that we deployed. Let's take a look at Cloud Run to see the current deployment process. And this toolbox is currently being deployed, and those are other tools that it's already been deployed.
Nice.
Yeah, so we're creating MCP server, right? And now we need to making sure the tool is working before we connecting that to ADK agent. And here is the command to diagnose, like making sure the MCP server is working. So I'm copy this. I'm gonna go back to the terminal. I'm gonna paste it. So what it does is first it will activate the environment, and then it will install the necessary dependency, and then we have this ADK run diagnose. So ADK run is one way to run ADK agent. We have ADK web that open in the ADK web UI. ADK run is directly you can interact them in the terminal. So here we are creating this diagnose agent that is just a testing agent connecting to our MCP server to test the functionality. And you can see that we're installing those dependency over here. And to test the tool, those are the how you want to test the tool, Io.
So it's tested in the terminal. So as Andy mentioned, ADK run is one method of testing with ADK, and essentially what it does is spin up a terminal interactive kind of GUI.
I mean, how do I mean, like anything you want to ask agent for using those tools?
Sure. Let's say look up the entry for Inferno Lash.
Look up?
What is the base power level? Yeah, let's start off with the first one.
Okay.
Now, it takes a little bit of time. So for those of you that are wondering, oh, my laptop or terminal is a little bit slow, don't worry. When you're running this for the first time, it's kind of establishing a lot of different environmental variables in the environment and a few other operations. So it may take 30 seconds.
It works, Io. You can see we have this user.
Yeah.
Now you can talk to this diagnose agent by, oops, I said the wrong thing. I'm going to copy this. I'm going to paste. Look up the entry for Inferno Lash. Okay.
The base power level of Inferno Lash is 85 damage points. Pretty
great.
Good. Pretty good. So
that means it's using the MCP toolbox.
Yeah,
right?
I was about to say, so Annie, what's happening behind the scenes here? If you can just do a quick iteration. Quick kind of
it's actually using the MCP toolbox we created.
Yeah.
And then it's connecting to that Cloud SQL, and then it's grabbing this data like 85 damage, and then you're showing over here.
Yeah, yep.
So next one. Okay, so it's casted this damage. Basically, it's dealing the 80 damage. We are actually connecting the API MCP server we just created to cast the damage. And the last one is we want to do some calculation. We are multiply with different magic, so that now it charge to deal 45 damage. So we're using that general function MCP server so that it will do some calculation. And that means all three MCP server is working as expected, and we can finally connect them to the real agent we created, right?
Yes, that's so.
Yes.
Yeah.
I'm gonna Control C to abort it. And let's take a look at what we've done so far. So what we've done is we create MCP server, we create external API with ADK. We also have this MCP server with general function that has mathematical calculation, right? So those are created by ADK. We also try this MCP toolbox so that you create this MCP server that can easily access and modify or connecting to your database. And next is you want to connecting those tools to ADK agent. And before we connecting, we need to know what are the ADK agent we want to create. So here we are creating this fire familiar with sequential agent, water familiar with parallel agent, and the earth familiar with loop agent.
Yep.
So I hope, do you know what are sequential agent, parallel agent, loop agent on the screen?
Yeah, great question. Sequential parallel loop agents are a different way of coordinating essentially multi-agent architectures. And the ADK or Agent Development Kit comes with prepackaged, classes and syntaxes for how do you organize, multi-agent teams. So obviously the most raw and basic kind of coordinator example.
Sequential.
Yeah, is that you have a coordinator agent and then you have sub agents and you give it to it.
Oh yeah, that's a hierarchical routing, right?
Hierarchical routing. That's the most basic, I would say, pattern of coordinator, and that will work for most of the time. But oftentimes, for that use case, you have to prompt the agent on how you want it to call the agents and in what pattern. But if you really just have a deterministic pattern that you expect for the sub agents, we always recommend these workflow agents. So ADK has a sequential agent syntax where essentially, as long as you put this sub agents as part of that sequential agent, it will call agent A, agent B, always in that order. Similarly,
in the fixed order.
Yeah. Similarly, for parallel agent, you may want agent A, B, and C to be running at the same time. And the best way of kind of coordinating that would be, again, through the parallel agent. The ADK makes sure that when that agent gets called, all three agents get delegated to at the same time.
That's actually something ADK is very specialized at, because imagine if you don't want to use sequential agent, you can just simply write a skill with workflow, or you can just in the prompt you say do A and do B.
Yeah, exactly.
But if you do the parallel agent in the prompt, you can say do them at the same time. It may not able to kick off the multi-thread, but with the workflow, it will definitely have those those running in parallel, and you get to control them. Like, I think that's also one powerful thing from ADK, that you can kick off parallel agent, and also the loop agent you can controlling the state that pass in the loop to do the check. So I think that's also one advantages of ADK, right?
Yeah, exactly. And then lastly, just to kind of give a brief overview of the loop agent. The loop agent is essentially kind of an analog of the for loop, if for those of you programmers out there. Sometimes you want to do something an X amount of times, and let's say you already meet the threshold for that criteria, you want to break out of that for loop. Similarly, for the loop agent, you may want a set of agents to be running the same set of logic up to a certain amount of time, or a number of iterations, or if essentially they reach their objective. So ADK has really good syntax where you can set the max number of iterations, and you can also kind of escalate out of that loop if you meet your criteria. So essentially, those are the three sub-agent or three team agent patterns with the ADK: loop, parallel, and sequential. And now Annie's going to walk us through now building each of these agent patterns in context of our use case.
Great. Thank you, Ayo. And let's take a look at the first agent, sequential agent. So basically, we want to have one Scott agent that connecting to that toolbox. Remember we have the toolbox to have different type of fire ability, right? So we want to have a Scott agent to grab one type of fire attack, and then we want to have an amplify agent connecting to that general function. Remember, general function doing the mathematical calculation, right? So we want to have one agent grab the attack, another agent to amplify the impact. So you want to run them in sequential. So that's why we want to connect them in a sequential workflow. And here is how we do that. We go to step 5, domain workflow. And the first step is, let's go to the agent file, agent.python file. So copy the file name. I'm going to go to this file, right? And let's first replace setup MCP. Then I'm gonna paste it by this code. So here is how you can connect using this MCP toolset with this URL, so that you can connecting to the MCP toolbox server, like MCP server we just created. Why we have SSE server parameter here? Do we have different prompts parameter?
Yeah, great question. There's HTTP, there's SSE connection parameters that you can set. Essentially, you're just defining your connection with the underlying MCP server. So when you see that function tools URL, remember we deployed that server to Cloud Run.
You can take a look. Yeah, so it should be the toolbox, this URL, right?
Exactly, yeah. So it has its own endpoint. So pretty much all we're doing through ADK syntax is defining that connection between that MCP server and the agent. And the way you do that in ADK land is MCP toolset.
Yeah, great. And in the same file agent, let's replace this worker agent. Just copy this. And we're going to paste it with the code over here. And let's take a look. So this is the Scott agent and amplify agent we just mentioned on the screen. So the Scott agent connecting to the toolbox, amplify agent connecting to this functional general MCP server. So let's take a look. The code, basically, we have the Scott agent. This is what the Scott agent does, and it's connecting to the toolbox tool. And the amplifier is connecting to the tool function. So that is the general function we just create. Oh, we don't have to create this one. This one is already created for you, but we check the code.
Yeah.
The next step is we want to put them together with the sequential workflow. So what we did is we create a Scott agent connecting to the toolbox. We create an amplify agent connected to the MCP server. And next, we want to making sure they run them in a sequential order. Right? So we copy this and we go to the replace sequential agent file and we paste it over here. So now we can making sure that we have sequential workflow agent that running those two things in sequential order. So if you swap the order, is that okay?
No. I mean, depending on your use case, you may have
in this case, you cannot.
This one you wouldn't want that to be the case because you want to scout and then amplify. But there could be use cases where it could be B then A or A then B. But for our particular use case, we care about the order. So hence the sequential agent.
Depends on your use case.
Yeah.
Great. So next, let's open an ADK web to test our agent. As you can see, we have a lot of command over here, but what you really care about is the last one, like ADK web. So those are just making sure you're in the right environment setup and you have the right variable configured, and then we can have this ADK web.
Yeah, and he's going to walk you through ADK web in a second, but essentially think of it as like a development UI where you can test your agents, evaluate them, interact with your agents, prompt them. So it's essentially just a nice UI for interacting with agents.
All right, Ayo, let's test the sequential agent we just created.
Let's do it.
So I'm copy this and I'm gonna paste to the terminal. Oh, I can see that we are using ADK web. Previously, we were using ADK run. What are the difference?
Yeah, ADK run, essentially you're in a command line interface prompting your agent. ADK web is a little bit more fully featured. It comes with a full development UI. You can prompt your agents, but you kind of see a visual response output. So this is really good for multimodal inputs. ADK web, you can record your voice and do other things. You can also kind of do evaluation, see traces. So ADK web is essentially your one-stop shop in a way for kind of testing and interacting with your agents.
Yeah, I really can't wait to see the ADK web UI and to test it. So we want to first test the fire agent, and this is an example prompt. I'm gonna prepare this.
Make sure that you navigate to ADK web correctly. There's two different ways of doing it. So you can either click the link that gets generated, or if you're using a Cloud Shell, so you're gonna see an output that looks something like that. Make sure that you click the underlying link and a new tab will pop up in your browser. Or you kind of click the top right corner of your terminal, which Annie can show you, and kind of go to the web preview directly.
Yeah. All right. So now we have this open. I'm going to show you. This is a web view. and change port, making sure change port to 8000 and change and preview. So it will open a new window that is ADK Web UI. Great, so we can directly talk to our agent on this web interface. And on the top left, we have a drop down and making sure we select file for our current use case. And let's ask a question to file agent, prepare this amplify strat using the Inferno Lash ability. And okay, let's see. It's doing, this is the agent, this is a tool. And let's see how the agent is going to do. So it will look up the available ability first. And from the result, it's getting the those are ability it gets. And then it's decide to use ability damage. It's look up again. Sometimes it just, using duplicate tool. But after the reasoning, it says, okay, the base damage is 85. Okay. So yeah, it's common to have some duplicated thing. And eventually, if you're using the amplify agent, so once it finds the agent you want to use, and then it's using the amplify agent to amplify the damage. So now you can see the final damage is 255. So that means we successfully run the sequential agent and connecting to the tools we just deployed to Cloud Run.
Yep.
And we are going to do a similar step for water agent and earth agent. So the water agent is, again, we'll go to the water agent file. So we go to the water agent file. Okay. Let me look. And now I'm going to search it. So now I open this water agent file and copy this setup MCP, paste it. You can see it's similar. We are using a similar MCP toolset and connecting that to the corresponding URL, right? So that URL is the one that we deploy to Cloud Run. And in the same water agent, we are creating this agent. So we're going to replace this with the water agent code. And you can see we want to run those 3 agents at the same time. Basically, we want to have this Nexus channeler and 4 channeler all together. And then we want to merge them. And you can see that we have this parallel agent first on the left. And then we're going to put together this parallel agent and the power merger to a sequential agent. So that we can making sure it's run the parallel first and then the power merger next. If you run the power merger first and the parallel next, then it's not going to synthesize the result.
Yeah.
So how are we going to do that?
Parallel agent. So very similar construction to sequential as we talked about. And all you do is wrap the sub-agents in a parallel agent. Yeah.
So you can see we have those 2 wrapped in the parallel. And then we have this channel agent and the merger in a sequential. So that's how you put them, you run the parallel first and then merge them afterwards.
Yeah, and it's also really kind of a powerful pattern. A lot of people think that you can only put kind of basic LM agents within a parallel agent or loop or sequential. But in reality, you could put a parallel in a sequential or sequential within a loop. So it's kind of interactive.
Yeah, great. So next step is, again, we're also running this to do the ADK wrap, but I'm going to do the test later together. Let's go to the Earth agent. So Earth agent, similarly, let's go to the Earth file. It's under, I think it's under the Earth agent file. And similarly, let's first connect the tool to the, I think let's first connect the, here I'm going to copy the setup MCP server, and I'm going to copy this. And first, let's connect the MCP server to the agent. Similarly, we have this SSE server parameter, and we have this URL. So I noticed that we've been using this SSE server parameter for MCP toolset. Do you think we can also use the HTTP parameter for our connection? What are the difference?
Yeah, so SOC is meant for server side events. So that's why we're using this in this particular case.
Yeah.
But we could do it the other way too. But that's just essentially what we're doing for this use case. Yeah.
I see. So it really depends on the use case.
Yes. Sometimes you want something that's more streaming.
Yeah.
And yeah. So it really comes down to the use case. Yeah.
Got it. So now we're creating this loop agent, and loop agent is first we're having this charging agent so that you're charging your energy and you're connecting those to the tool functioning, and then you're gonna check whether it's meeting the condition, right? So you're gonna run those two agents in a loop until the max iteration number is met. Like it's maximum 2, you can make it 5 or 4, it's your choice, or it's meeting the criteria. Okay, now let's copy the charging agent and also this loop agent to our file. So we have this charging agent already copied, and then let's put the loop agent. So this is basically having this running in the loop. What do you think is a good use case in the industry to have a loop agent?
I've seen loop agents be used for different use cases, but one that comes up often is for writing use cases. Or essentially producer critique use cases where you have one agent that produces some sort of output content, another agent that critiques it, and then the producer agent then factors in that critique and produces a new version of it. So think about writing an essay. You have one agent that's essentially writing the output, another agent that's essentially grading it, and then the agent kind of then takes another try at improving the quality of the essay. You do that many times until you either reach a point where you feel like the essay is good enough and you stop, or you just give it a max number of iterations. So that's just
great.
Yeah,
that's a really good example. Yeah. And let's take a look, because we test the fire agent before, and let's test the earth agent and the water agent.
Okay.
So the water agent, the parallel agent, right? So I'm gonna go back to the water agent. I'm gonna say unleash the wave of water. Okay. So if you see this arrow, that means you need to refresh your screen.
Yes.
Okay.
Refresh your terminal. So essentially, after a while, the Cloud Shell authentication will time out. So you just have to refresh, and that kind of re-triggers an re-authentication. And you may have to close. Great. You may have to close the terminal again. I mean, close the ADK web. But
I think it's okay.
Okay.
Let's go try. Unleash a tidal wave of power.
Yes.
Great. So it's supposed to run the parallel agent first and then the sequential agent next.
And it did so.
And yay! So you can also see the diagram over here. And we can also test the loop agent we just created.
Yeah.
And let's just go to the Earth and ask Earth agent a question. Begin charge and starting from 0. We expect them to keep charging until we have meeting the criteria. So it's charging starting from 0. Let's see whether it's having this in the loop.
Yeah. While this is running, what have you seen for parallel agents in terms of real world use cases? So everything that we're doing here has like a real world.
Yeah.
So what do you tend to see parallel agents used for?
I think parallel agent is similar in when we do a software design. We want to run things in parallel to improve the latency, right? So sometimes if things doesn't have dependency, for example, if you want to do a different type of search, like for example, when you plan a trip, you want to search for nearby museum, nearby food, or nearby concert, and then you can do the search at the same time and then synthesize the result. So basically, any type of task that you think they're not dependent on each other and you want to improve the performance, latency, improve the user experience, you can consider running them in parallel.
Makes sense.
To do that together.
I like that.
And also very interesting, I also have a really cool project, like a collab that's using parallel agent that's basically all the agent gonna vote, and then we're gonna pick the majority as a result. So if you're interested in that parallel agent use case, we can also link the collab in over here.
Yeah.
Okay, let's take a look. about the result. As you can see that they're running in a loop. So we basically keep charging, and check. So that means we have successfully finished all the type of agent. So we've been covered sequential agent, parallel agent, and loop agent. And we're doing the sequential agent like file agent, and parallel agent with water agent, and loop agent with earth agent. So thank you so much for everyone who attending today's session.
Yay.
And tomorrow, yay! But we haven't filed the both yet, right? So what we cover today is we cover different type of MCP server with ADK and MCP toolbox. And then we link
ADK
them.
workflow agents, as well.
Yeah, and then we have this workflow agent from ADK, right? And then we link the different type of tool to the agent. So now we have the specialist agent. So what are we going to cover tomorrow, Io?
So tomorrow we're going to be covering agent-to-agent protocol, or A2A. We're going to be covering plugins and callbacks in context of the ADK. So how do you inject custom logic at certain parts of the agent runtime before an agent is called or after? We're also going to learn a little bit more about agent state and memory. So it's a jam-packed session tomorrow. So please, tune in again.
Please.
Yeah. So until next time, and also tomorrow we're going to be fighting the boss in the cloud. So you don't want to miss that.
Fight the boss.
Yeah. But until next time, thank you for joining, and we'll see you next time.
Thank you.
Thank you. Bye.
See you next time. Bye.
Bye.